Hi, I'm going to share results from my recent paper modeling Mars's obliquity-driven CO2 exchange between its atmosphere, regolith, and polar cap. Mars has a primarily CO2 atmosphere, a polar CO2 ice cap, and a reservoir of CO2 absorbed in its regolith. Determining how much CO2 exchanges between these reservoirs over 100,000-year orbit-driven climate cycles is important for understanding Mars's climatic evolution. So I constructed a climate model of orbit-driven CO2 exchange, item 1 on the left. The model outputs a predicted thickness of alternating layers of CO2 and water ice in the CO2 cap, item 2 on the left, which I compared to the observed stratigraphy, item 3 on the left. This indicated that about 100 millibars of CO2, or about 17 times the current atmosphere, exchanges during orbital cycles. That's item 1 on the right. I also calculated the historical evolution of CO2 mass in each reservoir, item 2. And interestingly, regolith absorption decreases Mars's peak atmospheric pressure by about 40%, implying that near-surface habitable environments with liquid water are more difficult to create and sustain in Mars's recent history than previously thought.